Okay, so we now have problem number 5. Determine the resultant of the four forces and one couple acting on the plate. Specify the points where the resultant's line of action intersects the edges of the plate. So we have the four forces in here. We have the 4 kilonewton, we have your 5 kilonewton, so this 400, that is 300, therefore the slope of this force is 3 and 4. Hence, the slope triangle is 5. So we have the 10 kilonewtons, 60 degrees with the horizontal, and we have your 6 kilonewtons. So first, let us try to determine the components of the 5 kilonewton load. So the components of the 5 kilonewton force, so we have your Fx. So the x component is now equal to 5. Multiply this one by 4 all over 5. So we have 4 all over 5, or this is equal to 5 kilonewtons. So this is therefore the x component, and that is now equal to 5 kilonewtons. And the y component is equal to 5. Multiply this one by 3 over 5. 3 all over 5, or this one is equal to 3 kilonewton. So this is now your 3 kilonewton. So we have also the components of, so we have now the components of that 10 kilonewton force. So we have your Fx in here is equal to 10 cosine of 60 degrees. So this is therefore your 10 cosine of 60 degrees. And then we have your y component so the y component is equal to 10. We have sine of 60 degrees. So this is therefore your 10 sine of 60 degrees. So let us try to determine now the resultant of these forces, or of this force system as shown. So we have your Rx is equal to summation of forces in the direction of x up to the right forces positive. Okay, so we have no x component or horizontal component. Then we have this is equal to 4. Okay, so we have okay, so we have Rx is equal to, so we now have your 4 kilonewtons. And then we have this one in here, plus this is going to the right, so plus 10 cosine of 60 degrees. And then this going to the left, so that is minus 6. And therefore, your Rx in here is now equal to 3 kilonewtons. So this is 3 kilonewtons. So this is going to the right. So we get positive value, therefore it goes to the right. And your Ry is equal to summation of forces in the y direction, upward forces positive. So your Ry is now equal to, so we have your Ry, which is now equal to, so we have 4. So that's going up. And then we have minus 3. So that is minus 3. And then plus 10 sine of 60 degrees. This has no y component. And therefore, this is equal to 9.66 kilonewton going upward. So to determine now the resultant force R, this is now equal to the square root of Rx, which is 3 square, plus Ry square, 9.66 square, and the resultant is equal to 10.115 kilonewton. So this is going up to the right. Okay, so that is going up to the right. So the angle that the resultant makes with the horizontal, so your theta is now equal to the arctangent of Ry all over Rx. And this is equal to the arctangent of Ry is 9.66 kilonewton all over Rx is 3 kilonewton. And therefore, the angle it makes with the horizontal is equal to 72.75 degrees. Hence, the resultant is equal to 10.115 kilonewtons. So this is up to the right. So this is up to the right at theta x equal to 72.75 degrees. So let us try to determine now the intersection of the resultant force with edge AB. So I'm going to consider this one in here equal to x. So I'm going to resolve the resultant force at this point. So this is now your Ry. And this one in here is now your Rx. So if you try to get the moment of the resultant about point B is now equal to the summation of moment of all the forces acting on the plate about the same point B. So I will going to consider clockwise moment as positive. So your Rx has no moment about point B because it passes through your moment center B. So we have your Ry going into a clockwise direction. So your Ry, multiply this one by x. And this is equal to, so let's start with 4. Your 4 is going clockwise about point B. So that is equal to 4. And the moment arm is equal to 1,000 millimeter. And then we have the other force in here. This 4 in here is going clockwise about point B. That is positive 4. And the moment arm is equal to 750 plus 450. And that is equal to 1,200 millimeter. This has no moment. Your 3 kilonewton force in here has no moment about point B because it passes through your moment center. So we have this 10 cosine 60 and 10 sine 60 passes through the moment center and therefore has no moment. And we have your 6 is counterclockwise about point B. So that is minus 6. Now, the moment arm is equal to. So this is the moment arm. So we have 500 millimeter. And then we have a couple acting at the center of the plate, and that is 800 going counterclockwise. So we have minus 800. And therefore, the value of Ry in here is 9.66. X is therefore equal to 4960. So it's 4960. Hence, the value of X in here is equal to 4960 all over 9.66. And therefore, the value of X is now equal to 513. So that is 513.458 mm or millimeter. So that is from point B. That is from point B. Now, let us try to determine the intersection of the resultant force with edge BD. So this is now your edge BD. So I'm going to resolve the component of the resultant force at this point. So this is therefore your Rx, and this one is now your Ry. Okay, so if you try to take moment of the resultant force about point B, is now equal to the moment of all the forces acting on the plate at the same point B. So your Ry has no moment about point B. So I'm just going to consider that this one in here is now your Y. So we now have Ry has no moment because it passes through the moment center B. So we have your Rx is going clockwise about point B, hence we have positive Rx, and the moment arm is equal to Y. And this is equal to 4 by the moment arm 1,000. And then we have another 4 clockwise, so that is plus 4. The moment arm is 450 plus 750, or that is 1,200. So this has no moment again about point B. So we have the 3 kilonewtons again has no moment about point B. So we have your 6 counterclockwise, that is minus 6, and the moment arm is 500. And then we have a counterclockwise moment at the center of the plate, that is minus 840. So that is minus 840 kilonewton millimeter. So that is 840 kilonewton millimeter. The value of Rx is equal to 3. So we have 3y is now equal to 4960. 4960. Hence, the value of y is equal to 4960 all over 3, and this is equal to 1653 6.33 millimeter. Now, since the length of the plate BD at edge, the plate at edge BD is equal to 1,500. So you try to take note that this is greater than 1,500 millimeter. Hence, the resultant are will not intersect edge BD. So the resultant R will not intersect edge BD. Now, let us try to see whether the resultant force intersect edge CD. So that is now your edge CD. So I will going to resolve the component of the resultant at this point. So this is now your Rx. And this one in here is now your Ry. So we now have your Ry. Yeah? Now, let's try to determine now. I will going to consider that this distance of Ry from point D is now equal to x of 1. So if you're going to get moment of the resultant about point B is equal to the summation of moment of all the forces acting on the plate about the same point B, taking clockwise moment positive. So, we now have your Rx. Multiply this one by, so this is 750 millimeter. So that is now your Rx going clockwise. Multiply this one by 750 millimeter. 1,500. So it's 1,500 millimeter. 300, 450, and 750. So we have Rx multiply this one by 1,500 millimeter. Okay, so Ry is going clockwise about point B plus Ry multiply this one by x of 1. So this is equal to 4 about point B clockwise. 4 multiply this one by 1,000. So we have 4 multiply this one by 1,000. Now we have the other force in here is this 4. So we have plus 4 multiply this one by 450 plus 750 is 1,200 millimeter. Again, 3 has no moment about point B. 10 cosine 60 and 10 sine 60 has no moment about point B. So it's going counterclockwise. So minus 6 multiply this one by 500. And then we have a counterclockwise moment in there. So we have minus 840. So the value of Rx again is equal to 3 multiply this 1,500. And then we have Ry is 9.66 multiply this one by x1 is equal to 4,960 kilonewton millimeter. Therefore, 9.66 x of 1 is now equal to, so we have 460. Hence, the value of x1 is equal to 47.619 millimeter. And therefore, the resultant force intersect edge AB and edge CD. Hence, R, which is equal to 10.115 kilonewtons, intersects. So it will going to intersect edge AB. So it will intersect edge AB at 513.458 millimeter. That is from point B, and intersect edge CD at 47.619 millimeter from point D. So that is therefore the intersection of the resultant of the four forces acting on the plate. Again, 513.458 millimeter from point B and 47.619 millimeter from point D.